the comparison test second. That is, actually these tests are used for the testing purpose of a convergence of improper integral. अगर हमारे पास improper integral है, वो कॉन्वर्जेंस है क्या डाइवर्जेंस है, उसके लिए हमें टेस्ट यूज करना भी होता है. डायरेक्टली बिफोर कैलकुलेशन ऑफ दैट improper integral, we can use the different tests, test first, test second, and by using these tests we can discuss the given improper is either convergent or divergent. It is important. Actually, these are the tests which are used to discuss the convergency of or convergent of improper integrals. Actually, comparison test second, this is in the form of a limit. It is also called as a limit form. Mohit, Seema Thakur, Mohit Gaikwad, Sanskriti Upparwad, Nikhil Gaikwad, Adarsh Jangle, Rohit Kasale Kasar, Rutuja, Seema Thakur. ओके, ठीक आहे. आता आपण ह्याच्याकडे जाऊ. Okay, now see this, these are the unit number 3 and we are here comparison test for convergence. We have seen in the last lecture comparison test for the convergence first. Today we shall discuss the second. These are the limit forms of improper integrals. If integral from a to b and a is a point of a discontinuity, then we can write this integral from a to b f dx is equals to limit lambda tends to 0 positive a plus lambda to b f dx, where it is discontinuous at a, and if this limit exists, then we can consider, we can say that given improper integral is convergent. Then we can say that given improper integral is convergent. Okay, now see this is for improper integral at b, this is improper integral at both the end. If these limits exist, right side में जो भी limits है अगर वो exist होते हैं, then we can say that given integrals are convergent. Okay, now we shall discuss the comparison test. अपन यहाँ पे theorem discuss करना है comparison test का second. It is also called as a limit form of a comparison test. Actually, this is the theorem. Now we shall write the proof of this theorem. So statement of the theorem or statement of the statement of the comparison test. Statement: if f and g are, the two functions which are in a closed interval ab such that limit x tends to a f of x divided by g of x which is equals to L, म्हणजे f of x upon g of x चा लिमिट जर L असेल, where L is a non-zero finite number, then the two integrals, integral from a to b f dx and integral from a to b g dx, both converges or diverges together. This is the statement. परत एकदा मी statement सांगतो. If f and g are the two positive functions on closed interval ab such that limit x tends to 0 f of x divided by g of x which is equals to L, where L is a non-zero finite number, means there exists a limit. F of x divided by g of x. If L is a non, then we can say that the two integrals f and g both converges or diverges together. म्हणजे f converges असेल तर g पण convergence असतो किंवा g convergent असेल तर f convergent असतो. किंवा एक डायव्हर्जंट असला की दुसरा पण डायव्हर्जंट असतो. ओके, आय शॅल राईट दिस स्टेटमेंट. समजून घ्या, महत्वाचं आहे. इफ F and G are two positive functions in closed interval a comma b such that limit x tends to a positive, f of x divided by g of x which is equals to L, where L is a non-zero, finite number, then prove that, or then the two integrals integral from a to b f dx and integral from a to b g dx converge and diverge together ITA. Converge or diverge together at A. See this is the statement of this theorem. This is a very important theorem, students. You must know the statement of this theorem. मुलं क्लास करणार झाले तर मी पहा, तुम्हाला मी खूप स्ट्रिक्टली परत सांगायला लागलो. पहा, तुम्हाला सेमिस्टरचं हॉल तिकीट नाही दिलं जाणार. If f and g are two positive functions in closed interval a b such that limit x tends to 0 positive f of x divided by g of x which is equals to L, where L is a non-zero finite number, then the two integrals, integral from a to b f dx and integral from a to b g dx converge or diverge together at A. Okay, this is the comparison stage second. Now proof. Now we have to prove this theorem. आता याचा proof घ्यायचे. Write down proof. We shall write the proof. Proof is very simple. Proof. See this. Given that the functions f and g are positive in closed interval a comma b such that लिमिट किती आहे रे, डिव्हिजनचं लिमिट किती आहे सांगा, आन्सर सांगा. चला मी कंटिन्यू क्वेश्चन करणार आहे, तुम्ही कंटिन्यू आन्सर देत जायचं. नाव यू टेल मी द व्हॅल्यू ऑफ लिमिट. लिमिटची व्हॅल्यू किती दिलेली आहे, लिमिट x टेंड्स टू a पॉझिटिव्ह f of x divided by g of x which is equals to L. This is a given. Now see this, f is a positive, g is a positive, so f divided by g is also positive. F divided by g is also positive. Note that इथं f पण पॉझिटिव्ह आहे, g पण पॉझिटिव्ह आहे, म्हणून f डिवाइड बाय g सुद्धा कसं होतं रे स्टुडंट्स, पॉझिटिव्ह होतो. f डिवाइड बाय g इज ऑल्सो पॉझिटिव्ह. बरोबर आहे का रे. सो f डिवाइड बाय g इज पॉझिटिव्ह आहे, because we have given f is positive, g is positive, then we can write f divided by g is also positive. आता f divided by g पॉझिटिव्ह. आन्सर देत चला रे, प्रत्येकाने आन्सर द्या. आन्सर नाही दिलं पाहिजे. अभिषेक लवकर जॉईन व्हायचं. निर्मोही देशमुख मध्येच कधी नाही जॉईन व्हायचं. ऋतुजा ओके. साक्षी चाकूरकर वेळेवर जॉईन व्हायचं. So therefore we can say that this implies that L is greater than 0. Then according to the definition of limit, we can write, we have let, let epsilon be a positive number. We have to use the limit of definition of the limit, positive number such that L minus epsilon is greater than 0. There exists a neighborhood NBHD. Suppose open interval a comma c. Open interval a comma c such that a is less than c is less than b. For all x belongs to open interval a comma c. Therefore, we can write according to the definition of the limit, we can write, if L is the limit, then according to the definition, E mod of f of x divided by g of x minus L, which is less than epsilon. See this, परत एकदा सांगतो. Now we have to write this concept. स्नेहल टिंगरे मध्ये नाही जॉईन व्हायचं, लक्षात येत नाही का? एक वेळा सांगितलेलं मध्येच कधी येऊन जॉईन आले, इथं काय का पीव्हीआरला गेल्यासारखं वाटायला लागलं का रे? योगेश वाघमारे, योगेश कदम मध्येच कधी जॉईन व्हायला काय? आपल्या मनावर आहे. पीव्हीआरला जायचं झालं तर लवकर जातात, वेळेवर जातात, अगोदर जाऊन बसतात अर्धा तास तिथं रस्त्यावर वाट बघत, आणि इथं लेक्चर चालू आहे म्हटलं की 15-15 मिनिट 10-10 मिनिट उशिरा येतात. लक्ष काय रे, जमत नाही का सांगितलेलं? एक वेळा वेळेवर प्रेझेंट राहायचं. ज्यावेळेस हॉल तिकीटला याल ना, तुम्हाला मग समजेल काय काय नाही ते. नाउ सी दिस, given that the function f and g are positive in closed interval a comma b such that limit extends to a positive f of x divided by g of x which is equals to L. This implies f is positive, g is positive, means division is positive. अगर division positive है which is equal to L, so we can evidently write L is greater than 0. Now we have to use the definition of the limit. Let epsilon be a positive number such that L minus epsilon is again greater than 0. There exists a neighborhood a comma c, comma a is less than c is less than b. For all x belongs to a comma c, we can write mod of f of x divided by g of x minus L, which is less than epsilon. This is the definition of the limit. So this can be written as, आता यालाच असं लिहू आपण कंपॅरिझन फॉर्म मध्ये. This implies that L minus epsilon into g of x, हे का, हे L राइट साइडला घ्या, L लेफ्ट साइडला घ्या, which is also, this is actually 0 is less than mod of f of x divided by g of x minus L, which is less than epsilon. आता L ला राइट साइडला घ्या, इकडे लेफ्ट साइडला घ्या. L ला लेफ्ट साइडला घेतल्यानंतर कसं येतो पहा, इकडे पहा पॉसिबिलिटी कशी येते. इफ वी टेक दिस L ऑन लेफ्ट साइड, मी L मायनस इप्सिलॉन इंटू जी ऑफ एक्स, याला सॉल्व केल्यानंतर असं येतं पहा, लेफ्ट साइडला L मायनस इप्सिलॉन इंटू जी ऑफ एक्स which is less than f of x, which is less than L plus epsilon into g of x. Suppose this is equation number 1, or I have given equation number 2. Okay, this is suppose equation number 2. Now if we take the comparison, first comparison, now we can take the first comparison. Now L minus epsilon into g of x, which is less than f of x, for all x belongs to open interval a comma c. Open interval, say this. This implies that g of x is less than f of x. See this. this implies that g of x is less than f of x. That means yesterday we have seen the theorem. काल आपण theorem पाहिलेला आहे, g of x is less than f of x. मग g of x f of x जर कॉन्व्हर्जंट असेल तर g of x कॉन्व्हर्जंट होतो. आणि f of x सॉरी g of x जर डायव्हर्जंट असेल तर त्याच्यापेक्षा मोठा असलेला फंक्शन f of x सुद्धा काय होतो, डायव्हर्जंट होतो. दिस इम्प्लाइज दॅट if integral from a to b f dx, that is a to b म्हणा, or that is integral from a to c f dx converges at a, then by the comparison test first, कंपॅरिझन टेस्ट आपण फर्स्ट पाहिलेले आहे. काय पाहिलेले आहे, टेस्ट फर्स्ट L minus epsilon into integral from a to b g dx, that is integral from a to b g dx converges at x is equals to a. हे कंपॅरिझन टेस्ट वापरला. इफ g of x is less than f of x, टेस्ट फर्स्ट पहा, त्या टेस्ट फर्स्ट वरनं हे आपण लिहू शकतो. L minus epsilon is less than g of x, which is L minus epsilon into g of x, which is less than f of x. If f of x is convergent, then g of x is less than f of x, then definitely we can say by the comparison test first, g of x also converges at x is equals to a. आता from 2 also we can write, also from inequality 2 we can write, आता ही लेफ्ट साइड घेतली होती आपण अगोदर, आता राइट साइड घेऊ, f of x which is less than L plus epsilon into g of x. आता याच्यात f of x is less than g of x आहे. Then by the comparison test first, if f of x is divergent, then g of x is also divergent. So we can write, therefore this implies that if integral from a to b f dx, that is integral from a to c f dx, because we have considered c is a small interval of a b, a to c f dx diverges at a, then by the comparison test first, comma L plus epsilon, see this right side चा इंटिग्रल कोणता आहे, f of x is less than L plus epsilon into g of x, so L plus epsilon into integral from a to c g of x dx. इथं काय घेतलंय पहा, a to c घ्यायला पाहिजे ना. 1 मिनिट, इथं a to c घ्या, a to c, इथं चेंज करा रे, a to c. ओके, so a to c, that is, and therefore integral from a to b g dx diverges at a. Okay, this shows that, this implies that, so this implies that, इसका मीनिंग क्या होता है फिर, this implies that integral from a to b f dx converges and diverges or diverges with integral from a to b g dx. Converges or diverges with integral from g dx. Means if f converges, then g converges. If f diverges, then g diverges. Means convergent or divergence depend on each other, and hence proved. Hence proved. हे theoretical proof आहे. theoretical proof आहे. अनिकेत, राहुल केंद्रे, गोपाळ पवार मध्ये जॉईन नाही व्हायचं रे. तुम्हाला लक्षात येतं का सांगितलेलं? तुम्हाला लक्षात येतं का सांगितलेलं? चला मला क्वेश्चनचा आन्सर द्या. लिमिट इथं या हां सर्वांनी जे मला प्रेझेंट आहेत त्यांनी क्वेश्चनचा आन्सर द्या. मला स्क्रीनशॉट घ्यायचे. नाउ यू टेल मी द लिमिट ऑफ दिस फंक्शन स्टेटमेंट. दिस लिमिट ऑफ दिस फंक्शन एफ ऑफ एक्स डिवाइड बाय जी ऑफ एक्सचं लिमिट किती दिलं होतं रे? कोण केलं लेक्चर त्यांना लक्षात येतं पहा. नाउ यू टेल मी द लिमिट ऑफ दिस फंक्शन. फर्स्ट ऑफ ऑल आय शॅल एक्सप्रेस दिस स्टेटमेंट अगेन. इफ एफ अँड जी आर, थेरमची स्टेटमेंट मी परत एकदा सांगतो. इफ एफ अँड जी आर द टू पॉझिटिव्ह फंक्शन्स इन क्लोज्ड इंटरवल ए बी and limit x tends to a positive f of x divided by g of x which is equals to L, which is the positive real number, which is a real number, the finite real number, then we have to prove that f and g both are integral of f and integral of g both are converges or diverges together. This is given that. So how we have proved? We have proved that according to the given condition we have written. Here f is positive, g is positive, then evidently or directly we can write L is greater than 0 and L is greater than 0 लिहिल्यानंतर पहा मग we have to use the definition of the limit, that is f upon g minus L which is less than epsilon. So by comparison we can write this in this way. L minus epsilon is less than g of into g of x is less than f of x is less than L plus epsilon into g of x. So after the left comparison, आता फक्त एवढंच left comparison घ्या, एवढा part. So after the left comparison, L minus epsilon into g of x which is less than f of x, then we have to use the theorem comparison test first here. I shall take. So use the comparison. सीमा ठाकूर, दिगंबर इमदे दोघांनी सांगितले म्हणजे दोघांचंच कॉन्सन्ट्रेशन आहे. So we can write this. So by the comparison test we can say the convergence at x. Similarly by the comparison test first we can say that divergent together. Now we shall discuss some problem. आता example घेऊ आपण, problem घेऊ. अनिकेत वराटे, हर्षद दळवी, गोरे दर्शन, स्नेहल टिंगरे, निर्मोही, वैष्णवी भुतडा, ठीक आहे, झडके, साक्षी चाकूरकर. साक्षी चाकूरकर लेट होते, आत्ता जॉईन झाली का बघा. ओके. नाउ example. We shall discuss one important example. So this is also important. The improper integral. The improper integral integral from a to b dx divided by x minus a bracket raised to n. Now student, tell me this integral is improper at which point? See, this given integral is improper, but you tell me for which point this integral is improper. कोणत्या पॉइंटला हा इंटिग्रल improper आहे सांगा. So converges if and only if Now you tell me the answer of my question. See this is a given integral from a to b dx divided by x minus a bracket raised to n. This integral is improper at some particular point. That means at left hand. Okay, Digambar Imde, Rutuja Deshmukh, Sakshi Sanskriti, Sounda, okay, Harshad Yogesh, Saili Mukund, Saguna Amruta, Mira Sima Sakshi Pratiksha. व्हेरी गुड. म्हणजे सर्वांना समजतं कुठल्या पॉइंटला इम्प्रॉपर आहे ते. ओके, नाउ सी दिस आन्सर. लेट I is equals to integral from a to b dx divided by x minus a bracket raised to n. See this integral is improper at, see this integral is improper. एक मिनट हाँ. This integral is improper at x is equals to a. So a being only point of infinite discontinuity. So a being the only point of infinite discontinuity. Infinite discontinuity. If, first of that, if n is less than or equals to 0, then it has finite value. So the given integral becomes proper. लक्षात घ्या, if n is less than or equals to 0, then it has a finite value, so given integral become a प्रॉपर इंटिग्रल. म्हणजे निगेटिव्ह जर असेल, 0 किंवा 0 पेक्षा लहान असेल, तर दिलेलं इंटिग्रल हे कसं असतं, प्रॉपर असतं. परंतु इफ अँड ओनली इफ n पेक्षा लहान, 1 पेक्षा लहान प्रूव्ह करायचे, 0 पेक्षा लहान असेल तर प्रॉपर आहे. आता राहिला 0 पेक्षा मोठा आणि 1 पेक्षा लहान. सो इफ वी कन्सिडर n इज नॉट इक्वल्स टू 1, इफ केस for n is not equals to 1, n ची जर व्हॅल्यू 1 असेल तर ह्याचं इंटिग्रल किती येतं, लॉग ऑफ x मायनस ए. लॉग 0 म्हणजे इन्फिनिटी होतं. सो सी दिस इंटिग्रल a to b dx divided by x minus a bracket raised to n, according to the condition of the improper integral at the left end, we have to use limit lambda tends to 0 positive integral from a plus lambda to b dx divided by x minus a bracket raised to n. For 0 is less than lambda is less than b minus a. This is the condition. Now we have to solve this limit. Lambda tends to 0 positive integral from a plus lambda to b. So we can write x minus a bracket raised to n into dx. Okay, now calculate limit. It's a limit integration काय तर students. Now you tell me what is the integration of x minus a bracket raised to n. Now you tell me limit lambda tends to 0 positive. Sorry. We can write the integral of this function x raised to n असेल तर त्याचं इंटिग्रेशन असतं x raised to n plus 1 divided by n plus 1. So we can write this as x minus a raised to minus n plus 1 divided by minus n plus 1 over the limit a plus lambda to b. So we can write this constant term minus n plus 1 we can take out of the integral, sorry, out of the limit of this lower limit and upper limit. So we can write limit lambda tends to 0 positive 1 upon 1 minus n into, put this limit, if we take this in the out of the bracket, so we get, and remaining term is x minus a raised to minus n plus 1 over the limit a plus lambda to b. So it may be written as limit lambda tends to 0 positive 1 upon 1 minus n, we can write 1 upon x minus a raised to, आता मायनस कॉमन काढलं, मायनस मायनस प्लस केला म्हणजे n minus 1. ओके, 1 minute. So n minus 1 over the limit a plus lambda to b. So we can write limit lambda tends to 0 positive 1 upon 1 minus n. अभी देखो यहाँ पे लिमिट पुटअप करो, अपर लिमिट और लोअर लिमिट पुटअप करो. फर्स्ट अपर लिमिट, स्टूडेंट सांगा रे, नाउ यू टेल मी विच इज द व्हॅल्यू ऑफ अपर लिमिट. इथं अपर लिमिटची व्हॅल्यू किती आहे सांगा स्टुडंट्स. नाउ यू टेल मी द व्हॅल्यू ऑफ अपर लिमिट. इथं अपर लिमिटची व्हॅल्यू सांगा रे. So we can write the upper limit as 1 upon 1 minute. हाँ, okay, ठीक है. Upper limit is here. The upper limit is b. Lower limit is a plus lambda. Now put upper limit first and lower limit second. Okay, Darshan Gore, Amruta Khan. Now you tell me the upper limit. Put the upper limit. Then what will happen? So we can write 1 upon x minus b bracket raised to n minus 1 minus 1 upon, sorry, x means upper limit is b. So we can write b minus a raised to n minus 1. आता lower limit ठेवा, a plus lambda minus a means we can write lambda raised to n minus 1. So limit lambda tends to 0 1 upon 1 minus n, we can write 1 upon b minus a raised to n minus 1 1 upon, see this, lambda raised to n minus 1. अगर if we put lambda is equals to 0, if we put lambda is equals to 0, then this is actually, this is the integral from a to b dx divided by x minus a raised to n. See this, suppose this is equation number 2. Now if we put the limit lambda is equals to 0, then it goes to infinity. It has two possibility. If the value of n is less than 1, n ची व्हॅल्यू जर लेस दॅन 1 असेल तर हा पॉवर निगेटिव्ह होतो आणि तो न्यूमरेटर मध्ये जातो आणि याची व्हॅल्यू 0 होते. सी दिस, इफ n is less than 1, if n is less than 1, here if n is less than 1 काय होईल पा, then 1 upon lambda raised to हा मायनस लेस दॅन 1 आहे म्हणजे हा निगेटिव्ह येतो, मायनस समथिंग समजा मायनस येतो, तो न्यूमरेटरमध्ये जातो, समजा मायनस वॉट एव्हर मे बी सपोज वाय मायनस पी येईल. इफ वी टेक n is less than 1 then we get 1 upon lambda raised to suppose minus p. If we take on a numerator then we get lambda raised to p, and if we put lambda is equals to 0 then limit goes to 0, then second factor will be 0. If lambda is equals to 0 less than 1 then the limit of 2 becomes, we can write integral from a to b dx divided by x minus a bracket raised to n which is equals to, हा second factor 0 होतो, so we get 1 upon 1 minus n into the first term जसे असतं तसं 1 upon b minus a raised to n minus 1. इथे येतो minus 0 if n is less than 1. So we get the answer that is 1 upon 1 minus n into b minus a raised to n minus 1. Means this will be the finite. याची व्हॅल्यू कशी येते, finite. Suppose this is a 3. If n greater than 1 then limit of 2 becomes, therefore integral from a to b dx divided by x minus a bracket raised to n which is equals to, आता याचं if n is greater than 1, if n is greater than 1 म्हणजे n ची व्हॅल्यू सपोज इफ वी राईट n इज ग्रेटर दॅन 1, आता n जर ग्रेटर दॅन 1 असेल, n ग्रेटर दॅन 1, सो 1 अपॉन लॅम्बडा रेज टू n मायनस 1 विच इज इक्वल्स टू सपोज p 1 upon lambda raised to p. If n is greater than 1 then we can't write in the numerator, so if we put lambda is equals to 0 then 0 raised to p, limit lambda tends to 0, but it is not actually 0. असं नाही की लॅम्बडा टेन्स टू 0 आहे म्हणजेच ॲक्च्युअली 0 नाही, म्हणजे 0 रेज टू p which is equals to 0 which gives a value infinity. So the limit of this equation 2 becomes infinity, so which gives a infinity. Hence we can say that for n is greater than 1 integral of this function is divergent. If n is less than 1 integral of this limit is convergent. हा झाला first case for n is equals to 1. So we can write here the given integral is convergent, therefore the integral is convergent for n less than 1 and divergent for n n greater than 1. This is a case first for n is not equals to 1. Now we shall discuss case second for n is equals to 1. For n is equals to 1, आता n is equals to 1 असल्यावर काय होतं पाय, इंटिग्रल फ्रॉम a to b dx divided by x minus a bracket raised to n. If we put n is equals to 1, so what is the value, integral from a to b dx divided by x minus a. आता स्टूडेंट सांगा बरे, now you tell me what is the integral of this, integral from a to b dx divided by x minus a. If we put n is equals to 1, then integral of this function is log of, हे पण राहिलं ना लिमिट, इथं राहिला पहा लिमिट लॅम्बडा टेन्स टू राहिलं ना ते, ओके वी शॅल टेक लिमिट lambda tends to 0 positive integral from a to b dx divided by x minus a if n is equals to 1. Now see here, limit lambda tends to 0 positive, the limit of this is काय तर लिमिट सांगा, सॉरी इंटिग्रेशन सांगा. नाउ यू टेल मी द इंटिग्रेशन ऑफ 1 upon x minus a log of x minus a over the limit a plus lambda to b. So you can put limit lambda tends to 0 positive, put the upper limit log of b minus a minus log of, very good, ऋतुजा, ऋतु b, ओमकार बिराजदार, अमृता गोरे, प्रीती करंडे, खराडे प्रीती, ओके व्हेरी गुड. लॉग ऑफ, आता अप्पर लिमिट ठेवा, दॅट मीन्स लॅम्बडा. आता इथं जर तुम्ही लिमिट पुट केलात, इफ लॅम्बडा टेन्स टू 0 then the log of lambda means log of 0, log 0 goes to infinity, whatever may be log of b minus a minus log 0 means infinity, which gives as a result infinity. This therefore the given integral is divergent for n is equals to, sorry, n is equals to 1. ओके, मग कन्क्लुजन कसं झालं पहा, हेन्स फायनल कन्क्लुजन येतं, हेन्स the given integral from a to b dx divided by x minus a bracket raised to n has, number 1, if n is less than 1, if n is less than or equals to 0, then convergent. If Leo, 1 minute, if. Second, if n is less than, n is, see this, if n is greater than 1 divergent, n is less than 1 convergent, see this, n is less than 1 la convergent. So n is less than 1, then convergent. Third, if n is greater than 1, then divergent. And fourth, if n is equals to 1, then divergent. Means you note that the given integral is convergent only when if it is n is less than 1, and henceforth the given integral is convergent only when n is less than 1. 1 असताना किंवा 1 पेक्षा मोठा असताना n ची व्हॅल्यू डायव्हर्जंटच होतो, अँड हेन्स प्रूव्ड. अशा पद्धतीने हा थेरम प्रूव्ह होतो, लक्षात घ्या. ओके, हा खूप इम्पॉर्टंट प्रॉब्लेम आहे, महत्वाचा प्रॉब्लेम आहे, ठीक आहे. ओके, इथं आपण मग स्टॉप करू. काही अडचण आली तर विचारा, काही अडचण नाही आहे. काय अडचण आहे का रे स्टुडंट्स? इफ यू हॅव एनी डाऊट देन यू कॅन आस्क. मुकुंद शिराढोणकर मध्ये जॉईन होतो रे मुकुंद. इफ यू हॅव एनी डाऊट देन यू कॅन आस्क निखिल गायकवाड, प्रतीक्षा शिंदे, स्नेहल टिंगरे. नाउ यू टेल मी, इफ यू हॅव एनी डाऊट देन यू कॅन आस्क. याच्यात काही डाऊट आहे का पहा. दोन केसमध्ये करा. फॉर एन इज नॉट इक्वल्स टू 1, एन इज नॉट इक्वल्स टू 1 मध्ये परत दोन पार्ट येतात. एन लेस दॅन 1, एन ग्रेटर दॅन 1. एन लेस दॅन 1 ला कॉन्व्हर्जंट होतो, एन ग्रेटर दॅन 1 ला डायव्हर्जंट होतो. आणि सेकंड केसमध्ये फॉर एन इज इक्वल्स टू 1 घेतला तरी डायव्हर्जंट होतो. म्हणजे टोटल कन्क्लुजन असं मिळालं, एन इज लेस दॅन ऑर इक्वल्स टू 0 देन द कॉन्व्हर्जंट, एन इज लेस दॅन 1 then convergent, n is greater than 1, divergent, n is equals to 1,